Okay, we're going to work through our first free response question, looking at review material for the AP exam coming up. So this question is review free response question A. The graph is given as a graph of the derivative of f, which is f prime, intervals 0 to 10. They also give you an initial condition for f, not f prime, that f of 0 is equal to 2. Part A. On the interval 0 to 10, find all values x for which the graph of f has a point of inflection. So remember, for graph of f being a point of inflection, we're looking for a change in signs of the second derivative. So if we're using the graph of f prime, which is this, we're looking for where f prime changes directions. So there is a sharp turn here, but f prime is not changing directions. It's going from increasing to constant, decreasing. So the only place where f prime changes directions is right there. So f has point of inflection at x equals 7 because f prime changes from decreasing to increasing. What's important to note is that we are referring to f prime. That's the graph that is given. Part B, suppose the graph given above, y equals f prime, represents the velocity of a particle. So f prime is the velocity of some particle that's moving along the x-axis on the interval 0 to 10. Determine the intervals for which the particle is moving to the left. So the particle is moving to the left when the velocity, which is equal to f prime, is less than 0. So the particle is moving to the left on the intervals. I'm going to use interval notation here. On the intervals, let's see, when is the velocity negative? That would be 0 to 1 and 6 to 8 because v equals f prime is less than 0 on the intervals. Probably don't need that last part on the intervals. Part C, g of x is an integral defined by 1 to 2x of f prime of x dx. Find g prime of 5. So g prime of 5. So first let's find g prime of x. So when we take we're going to use fundamental theorem here. It's an adaptation of the fundamental theorem. When we take the derivative of an integral with a lower bound, see the lower bound is a constant, the upper bound is a variable expression of x. So we plug in that upper bound, f prime of 2x, but then we have to apply chain rule here. So g prime of x is equal to f prime of 2x times 2. So then g prime of 5, replace the x with a 5, and we get f prime of 2 times 5 is 10 times 2. Well, f prime of 10, I believe we can look at the graph to find f prime of 10. This is f prime, so f prime of 10 is a value of 2. 2 times 2 is equal to 4. F of 4. Now this is the graph of f prime, so we're going to find f of 4. This is also going to be a point when we're using this information. F of 0 is equal to 2. So we're going to set up fundamental theorem to get backwards to f. So the integral, I chose 0 because that was the initial condition that was given up here. Maybe it's 1, maybe it's 2, maybe it's negative 1. But in this case it's 0. So 0 is our lower bound. Upper bound is 4 because we have to get at f of 4. F prime of x dx is equal to f of 4 minus f of 0. Please show this. You will get a point for fundamental theorem, and that is the fundamental theorem right there. Let's plug in values. This is an area calculation, 0 to 4 of f prime, so go up to the graph. Find this area here. Those two are going to cancel each other out, and we're going to go all the way to there, which is a square, 2 by 2, so that's positive 4 above the axis. So positive 4 is equal to f of 4 are unknown, and f of 0 is 2. Add 2 to both sides, and we get f of 4 is equal to 6. Last part of it, it's a limit. More than likely, you know, if they're going to have a limit on this exam, it's going to involve, on the free response portion, it's going to involve L'Hopital's rule. So let's take a look and see if it does. h of x is equal to a definite integral, okay, of f prime, k of x is equal to x minus 1, yada yada. Limit as x approaches 3 is this. So let's try to use direct substitution, which we know is our route of always starting, at least for limits. So limit as x approaches 3 of the numerator, k of x minus f prime of x equals, so this limit as x approaches 3 of the numerator is equal to k of 3 minus f prime of 3. K of 3, plug it in there, 3 minus 1 is 2. F prime of 3 is going to be on the graph. Where are we at 3 and we're at 2, so 2 minus 2 is 0. So the numerator is 0. The limit as x approaches 3 of the denominator h of x is equal to h of 3. And h of 3, now look at h of 3. H of 3 is the integral between 3 and 3 of f prime. Well, the two bounds are the same. Stop right there, 0. So we did get a case where we're going to use L'Hopital, so you must show this, must show that separately. Do not write 0 over 0. Okay, so let's use L'Hopitals. Let's take the derivative. So we have the limit as x approaches 3, so we're still going to evaluate a limit as x approaches 3, but now the derivative of the numerator is k prime of x minus f, it's a minus sign, double prime of x, the derivative of f prime, h prime of x. So it looks something like that. And now we're going to have to find k prime. We don't want our limit anymore because we're going to evaluate now at 3. K prime of 3 minus f double prime at 3 over h prime of 3. So k prime of 3, well, k prime is just 1. The derivative of this function is just 1. And we plug in 3, we still get 1. So 1 minus f double prime at 3. So that would be up here at the graph. Go look at 3. And it would be the value of the slope, the derivative of this graph. So the derivative at 3, since it's horizontal, is 0. And then h prime of 3, well, h prime, the derivative is of an integral is where you just plug in the upper bound. So that would be f prime of x. So f prime of 3, well, this is the graph of f prime, so the value at 3 is 2. So our answer is 1 minus 0 over 2, or 1/2. Sorry, I jumbled up there at the end and kind of ran out of space. But take a look, go over your solutions, and let me know if you have any questions.